So, welcome back. We are going to talk about slide step 20, and I think I'm going to do probably 21 in this block as well. So, let's start talking about changing the flow of our program. We have talked about the basics. We've talked about use modern Perl. We've talked about print and say functions, the difference being that print does not have any \n, any new line characters, but say automatically comes with a \n at the end of your output. So say is a lot like print line, if you are familiar with that from Java. We've talked about interpolation versus non-interpolation. We've talked about using chop and chomp along with the diamond operator for getting input in from our users. Remember that the enter key adds a \n to the end of input, so we always want to chop our input from the diamond operator. Excuse me, chomp. I can't remember if I said chomp or chomp there, but we want to chomp it so that we get rid of that \n. That's all that chomp does. We've talked about variables, which are called scalars in Perl. We've talked about the arithmetic operators, and we've talked about concatenation, repetition, and basically the plus equal shortcut. So now we're going to do something other than go from top to bottom in our code. We're going to add the if statement to it. And we're going to do this in this particular video. Perl has a couple others that they use, but we're going to keep it simple. We're only going to use the if statement here. So here is a very simple program. Let's go ahead and there we go. Now you can see it a little bit better. Would you like to see the 11 a.m. showing of Casablanca? My dollar answer is the diamond operator. We chomp dollar answer. If the answer is yes, then we'll print a statement out. Please notice the structure of the if statement. The if is the key word. It's like going to grandma's house and hitting a T intersection in your car, right? You have two choices, only one of which is true. If the left branch takes you to grandma's house, that's the true branch. If the right branch takes you off into, some spooky haunted woods somewhere, that's obviously false. That's the wrong direction to go. And that's all that this does. So if the answer that our user typed in is YES, then and only then do we do the code that's inside of the curly braces. Notice that the if statement itself does not have a semicolon. It kind of differs from the code that we've been talking about so far. Up until this point, only the shebang line did not need the semicolon behind it. But if statements, while loops, and a couple other things get by with that because they use the curly braces as, let's call it punctuation instead. So I'm going to hit that. Let's go over here to this. And I can't remember what I called it here. Oh, Casa1. So let's vim Casa1.pl. Again, would you like to see the 11 a.m. showing of Casablanca? My dollar answer is the diamond operator. Chomp dollar answer gets rid of the \n. I've added one if statement in there so that we don't just get a blank screen when we make anything other than yes. So yes, no, and let's see what happens when we run it. And we put in something other than yes or no. And we're going to Perl. Would you like to see the 11 a.m. showing of Casablanca? Well, I don't know. Well, that gave us nothing, right? Remember, if you type clear, you get back up to the top, but everything that we've done so far is still listed up there. Whoops. So let's try it from here so it's easier to see. How about we say yes? Okay. Now let's try capital Y-E-S. That didn't get us any joy. Let's try no. Again, oops. I forgot to run the program first, didn't I? Let's try no. That's a miss on a great film. So let's try. Let's try one more. Let's try no. So the only way that the input matches our two lines is if it matches exactly. So at the beginning, what you'll have to do is in some way communicate with your user that they have to type it in a certain way. Now we've got ways of changing that later on, but for now, this is the only thing that you can do. If you want them to say yes, what I would generally do is I'd put a little caveat behind that, put a pair of parentheses up with yes or no, just the way I wanted them spelled. That would help clue them in to what you're expecting as an answer to the question that you're answering, or you're asking rather. Now, I want to do one more little doohickey here. What happens if we don't chomp this? Okay, so we've seen that we can type YES or no. Let's see what happens when we do not chomp. Forgetting to hit the insert button. So we're going to go down here and just comment that out. Remember, this is an interpreted language, so we don't have to go through any steps to compile or anything. We just make the change, we save it. So what do I want to do here? Oh, YES. How come it didn't work? We saw it just a few times ago. Let's run it again and try no, because we know that no doesn't, or no works, but it doesn't work. The reason being is that what we're actually testing for now is a word without the \n. So let's go back up here and let's try something different. I'm only going to do this for the yes, and then we're going to move on. But I'm going to hit my insert key and do \n. Now, it doesn't look like much of anything, right? I'm also going to change my quotation marks from non-interpolative to interpolative. Wow, that's a hard word to say. But let's see what happens. So let's go back into this code for a minute. So since we are not chomping $answer, the only way we match it is with yes \n. That's that invisible \n that I was talking about. So here, in order to make this work the way we expect it to, you don't have to have single quotes. You can use double quotes in this because there is no interpolation going on. We don't need to have interpolation because we're taking care of the \n with chomp. It's not important enough for me to change it. And again, if we run that again, YES, that'll be 850, please. So remember, when you're doing input from your user, always chomp that input before you plan to use it in your code. All right. Now, let's go ahead. I'm not going to even bother with the PowerPoint. Well, I am going to bother with the PowerPoint, but I'm not going to bother with flipping back and forth between them. I'm going to make that just a little bit bigger so we can read things out. That's good enough, I guess. So that was our first introduction to the if statement. Here is the generic if statement. If some condition is true, then we execute the code that's in the body that is between the, excuse me a minute. Once again, I had a little friend come in from the outdoors. I don't know why. So the if statement, we do a condition inside of the parentheses. If $x equals yes, then we would do whatever code we've got inside of the curly braces. Let's see another example over here. So this is the same kind of thing that we've had before, except what we've got here is the Carnegie and Ritchie style of bracketing. That's this curly braces. Carnegie and Ritchie says it's better to have it on the same line with the if statement. I disagree. I have always, for me, put it on the line below. The reason being, that way I can highlight this in the compiler, or I could even put a ruler up against the screen and tell which curly brace goes with which particular if statement or other programming piece. I prefer, as I said before, the BSD, the GNU style is what we used to call it, which keeps the braces on separate lines. And as I say, most of the examples that I do, I am going to use the GNU style bracketing with the bracket opening up below the if statement. I don't care which one you do, but you need to go ahead and stay consistent with it in your programming. So remember that we backslash the $, backslash 850. That allows the $sign to come out in the output of our particular piece of code. So there's my $sign. Remember the slide we talked about in can't remember last week or the week before, where we talked about using the backslash with normal characters to bring out their weird meanings, or the backslash with quote unquote weird characters to bring out their normal meanings. Like backslash, the @ symbol will allow us to see the @ symbol on the screen. Backslash double quotes will allow us to see double quotation marks on the screen. And go back and review the escape character slide. I told you that was one that would be very handy if you memorized it. Now, since we're not using interpolation in this sentence, the $sign will come out just fine. Remember that interpolation means we bring out the hidden meaning in a variable. So if we had double quotes around this sentence right now, it would be looking for a value inside of something called $8. And for us as coders in Perl, that just doesn't work. The concatenation and the \n in double quotation marks, that's perfectly fine. And it's the same situation between both of these. The only difference here is we're sending one argument through into the print statement. Here we're sending two. We're sending the non-interpolated sentence plus the \n. Now, ignoring, there we go. That will be 850, please, \n. Why does that not work? I think it's pretty easy, right? We just talked about it with the $sign here. It's the same thing with the \n. Unless we send that through as an interpolated escape character, it's not going to work. We're not going to get the \n, and then we're not going to have our cursor be on the line below. So that's definitely not something we want to do. And there we go. Perl print rule of thumb number 2, / normal characters to get their weird meanings, and again, / weird characters to get their normal meanings. So the condition of an if statement is an expression. It's a mathematical expression, basically. So if $answer equals yes, or if 4 times 5 is what? It's 20, right? Is 20 ever false? No. So this statement, if 4 times 5, is always true. If $answer, is that true or false? Well, if something's in $answer, it's absolutely true. And we'll talk about the difference between true or false here in a few minutes. If chop $answer, well, that would be fine as long as there were more than 2 characters in $answer before we chopped it. If there's only 1 character in $answer and we chop it, we come up with an empty variable, right? If answer holds the letter I and we chop it, I goes away and we just have an empty variable. That would be false. So here's what is considered false in Perl. 0 or 0.0, decimal number 0. Single quotes right next to each other or double quotes right next to each other with no empty space in there. Double quote or single quote 0, that's considered a string, whereas the first 2 is considered a number because we don't have quotation marks around them. An empty list, if we just said print and had the 2 parentheses there, that would be an empty list. So we wouldn't send anything to the print statement in that case. We'd just have a line of nothing on the screen. Undef is basically a variable that hasn't been initialized yet. We don't know what it is. In Perl, everything else is true. So here's an example. We are doing our shebang line. We're using our Pragma modern Perl. We're declaring a variable, my dollar variable. But notice we are not initializing it right now. Now, not logic is what this is. So this says if there is nothing in variable, then we're going to do what's inside the curly braces, because if not variable is true, and it is, we have nothing in it, then we're going to output variable has no value. So once we get through that, line 7 says, say output $variable, or say math $variable times 2. Well, remember, if we don't have anything in it, we can assume in Perl that it's 0. So even though we don't have a value in variable, it's going to assume that 0 is there. So we'll actually get output from these 2. But it's still going to give a warning that we're using a variable that has not been initialized, that hasn't had anything put into it. Now this 9, 10, 11 is kind of cool, because this says if there's nothing in variable, then I want you to assign the value of 42 into $variable. And I think I've put an extra print statement at the end of this one so that we can see what the output really is. So let's ls space minus l here again. And you know what? I don't remember what I called it. That's why you shouldn't just willy-nilly name things. So let's just go ahead and do it. Oh man, I don't really want to do it that way. Let's do this real quick. Let's open up Windscape. again with me, continue. So we're going to go down here and back up into public, right? We're already in public. So we need summer 20. And there's Perl. So let us them what the heck? ifs.pl. Sounds good to me. So I am going to come back to the slide. And that little window is always in my way. That one it? Yeah, there we go. The only reason I'm doing this is because the copy paste on this doesn't work. Now, I added it in WinSkip, but it doesn't look like it's there. All we have to do is right click and refresh, and it should come back in. And there is ifs.pl. I'm going to open that up, and we're going to paste it here real quick. I'm not going to make it look pretty right now. I just don't have time for that. Neither do we. So we're going to do that. Going to move the silly picture around again. I wish I could get rid of it, but I haven't really looked at it and figured out how. So there we go. There's our code. I do want to, as I said before, add one more thing to it. It would help if I got out of the visual box and hit the insert instead. And then we want to print okay, the only thing I've added here is a print statement so that we can see what's going to happen here. Now, very first line, variable has no value. And we expected that because that's what the if statement says. If there's nothing inside of the variable, and this says if not variable, or if there's nothing inside of it, we need to go ahead and print variable has no value. So we're checking for a false condition, and if the condition is false, it means true. And that's going to confuse the hell out of you, but that's literally what it's checking for. It's checking to see if there's nothing in variable. Then we're going to output variable and variable times 2 with output in math. And if we go back to our Vim window here, whoops, wrong one, there we go. So variable has no value was the first one, then use of uninitialized variable in concatenation or string at ifs PL line 9. And look at this, our output is nothing. And then we have the exclamation point at the end, which was part of our text. We again get use of uninitialized value variable in multiplication at ifs PL line 10. 0 times 2 is 0, so we get a 0 there. Then we say in the code, if there's nothing in $variable, assign the value of 42 to it. So again, we are looking at an if statement that is true. If there's nothing in it, then we're going to add 42 to variable, and this just prints out the value of variable. All right, enough said. So here's another one of those good slides to kind of keep your eye on. Mathematically, I should say, perhaps, when you're testing numeric values, when you know you're going to do numbers, If X is greater than Y, less than Y, etc., there's greater than or equal to and less than or equal to. This is just the way we would do things in math. It's just our expression looks a little bit different than those that I used in the math department. String values, though, are a little bit funkier. But if you look at it, it makes sense. GT greater than, LT less than, GE greater than or equal to, less than or equal to, EQ for equality, and NE for not equal. Let's go up and look at numerically. When we're talking equality for numbers, and I think I mentioned this when we were talking about the assignment operator, the single equal sign. This says, is $X the same thing as $Y? That's my equality statement right there. It's two equal signs back to back. Not equals is the bang, the exclamation point, and the equal sign. So really, it should be relatively easy for you to kind of get that stuck in your head. Not necessarily the greater than, less than, because other languages deal with this in other ways, but at least the numeric comparisons. Okay, let's go here. The question is the word capital H hello less than or greater than hello? And it's actually less than, because capital letters, there wasn't any stuff about shouting when you hit caps. But in the old days, the first letters that were created were capitals. We didn't care about whether or not they were lowercase, uppercase. It was just amazing to see any words come out from a machine. We can look at the ASCII chart, but I'll let you do that on your own. But ASCII sorting is slightly different from sorting things with, alphabetical sorting, for example, because a lot depends on whether the letter is capitalized or lowercase. Lowercase letters came long after the uppercase did, so the uppercase letters have actually got smaller ASCII numbers. So let's check this out. If my $A, well, not if, my $A is 62, my $B is 7. If $A is less than $B, we'll print, hey, $A is less than $B. But notice we are not using the numeric inequality here. We are using the non-numeric. So LS minus L, I think I've got this one. Maybe I don't. Nope, that's counting. Okay. We're a couple slide sets off from that. So let's go back in here. And whoops. Let's then count. Not count. What are we doing here? See, the counting screwed me up. Now, if two. So now I'm going to go back in here and let's see what happens when we run this code. Crying out loud. And again, refresh. You could also hit Control R. That would do the same thing. So let's Perl if2.pl. Oh, v-Perl or v/Perl. That's not right. Hey, 62 is definitely less than 7. Again, we're talking about ASCII values. And ASCII values are designed Well, primarily for non-numeric values. We don't want to sort with ASCII, basically. We want to sort with either numeric or non-numeric. And I think the next one that we've got is we're going to come back in and change the less than there to a numeric. No, I take that back. We're going to do the equality first. So $A is 1, $B is 2, and if they are equal numerically, we're going to say, hey, they're equal. All right. So let's vim if3.pl, right, and quit, and we're going to come out here, and again, you can do Control-R. That will refresh things too. Well, you got to be in the, there we go. So let's grab an if3, and we're going to Control-V to paste that in there. Let's save that. Kill it. Come back here to Vim, and let's Perl if3.pl. So argument 2 and 1 are not numeric in a numeric equality. But then again, since there are 3 characters in there, basically it just said, yeah, they're equal. So both of these last 2 things we talk about are, kind of think of them as false positives. You know, this says definitely that A was less than B. This says definitely that A and B are equal, but they're really not. So let's try another one over here. Let's do it here. Let's just go back into this Vim and let's do the non-numeric equality. So let's see if A and B are the same non-numerically. So let's Vim if3.pl. Oh, come on. Hit the caps lock key. So what I want to do is come down here and remember that EQ is what we use when we're comparing strings, words and letters and so forth. Now, let's try this again. We don't have any output because it didn't trigger the error messages. So let's go put one more thing in here. We've got an if statement that says if A is the same as B, we print out that they're equal. What was our output again? I can't remember. Oh, we got no output. But 1 and 2 are not equal. They're different words. So let's put if $A is not equal to $B. Okay. So now the only thing I've done there is I've added one if statement. So if they are equal, we'll get, hey, A and B are equal. If they're not equal, we'll get they ain't equal. And yes, my English teacher answered rolling in their graves, but that's okay. In with the caps lock. And we see they're not equal. Let's do one more change here. So we're going to go back up, and B is going to be insert 1. Okay. Hey, 1 and 1 are equal. Cool. This seems kind of silly and pedantic, but this is one of the foundational things that you have to learn. And if you get this in your head, you'll go a long way with just being able to do if statements. Now, there's a new Perl operator out there called the numish operator. It uses 2 tildes. Again, that's that little wiggly character above the accent mark, the upper left of your numbers on the keyboard. And it's a pair of those. So what they're doing is they're allowing you to compare unequivalent items. So you can compare the character C with a number and see if they're the same. It's easier to just do it this way. So we're going to go ahead and take a look at this with the numish operator. We've got A as 1 and B as 2. So let's come back out here and whoops. Num1 for the numish operator. And again, we want to be in here, Control R. Let's find our num1. Oh, do you know what I didn't do? Gotta save it. So there we go. Now Control R, and you saw it pop with the numish. There it is. You can Control S to save things too, by the way. So let's Perl num1.pl. Smart match is experimental. Oh, we've used a different one in num1 line 8. So let's see if we can figure this out here. Well, I don't like the num1 or the numish operator. But what's happened is that Odin is not allowing us to use the numish operator. So ignore that for now. When you get into a different Perl environment, you can come back, haul these out, and try it again. But the smart match error says, basically, we're not allowing you to use this here. Which is one more thing that is a shock to me, quite frankly. Whoops, that's the next set. Let's come up here and we're not going to do any of these because they all use the numish operator. We're going to replace numish with, in this case, the EQ, the non-numeric equivalency. And I'm going to just go right on to this one because this is all of the things I want to talk about in one slide, in one program. So let's vim pl. Whoops. We can't have that /. That'll make things bad. The unknown mark was when I fat fingered an extra escape key in there. So let's go back to here. And again, we're already in here with that. Let's R. I didn't want you. I'm going to Control R. There we go. And we want to find if else. Oh, there it is. And we're going to paste. No, we're not going to paste. The wonders of modern technology. Now let's try this again. There we go. was about to hit escape colon run quit. Control S when we're out here in the Windows environment. I'm going to kill that. I'm going to go back to Vim tool. So let's Vim if else.pl. And let's cut this apart a little bit. It would help if I had the insert key, wouldn't it? Yes, it would. So here's what's going on. The first part there, we should all be familiar with that by now. That is just getting an answer in from our user. The second is the first if statement. But we're only going to have one if. Remember I talked about stopping at the T intersection on the way to grandma's and one direction was true and one direction was false? This gives us the ability to have many more exits. So if answer is yes, it's absolutely true and you go to grandma's house. Or you'll go see Casablanca. Else, if the answer is no, we can specify with the else if another comparison in there. And our final catch-all is if we don't go either to the movie or not the movie, or we go watch Alien versus Predator instead, that's where the else branch comes in. Anything else that we enter is kind of caught up in the else. So I have two words that are going to be successful with the program. Yes or no. That will get a specific response. Any other word I type is going to print, I'm sorry, I didn't understand that. So the other thing that I said we needed to do here because of the Odin setup, we need to delete that and if answer EQ, because that's our non-numeric comparison. And get rid of the two numish tildes. Okay. Notice, by the way, that the else branch doesn't have a condition associated with it. That's because it's a catch-all. It's anything else that we type is going to hit the else branch and receive a personalized response, even if it's, I don't know what the hell you're talking about. So let's take a look at this. And let's Perl if else. Would you like to see the 11 a.m. showing of Casablanca? No, I am a poor, wandering bard living on my wits and my sword. I'm sorry, I didn't understand that. Obviously, this is not yes or no, right? So since it's not yes or no, small case letters, it says, I don't know what you're talking about. Let's try it a couple other times here. Let's try yes. Boom, that'll be $8.50. Let's try no. Okay, but you're missing an excellent movie. If you've never seen Casablanca, y'all gotta go ahead and do it. Just, you know, do the Netflix thing. I'm sure it's on Netflix. So let's go back to our PowerPoints and see where we're at here. We're almost done with this set, I think. So all this slide is telling you is that you can do as many else if branches as you want or need. So in this case, the only difference between the one we just saw and this one is lines 12 through 14. And all 12 through 14 do is add a garble. So if we type garble in after the prompt, after the question that we ask up there in line 3 and 4, it will put out certainly. But anything else again If it's not yes, no, or garble, we'll put out, I'm sorry, I didn't understand that. So I don't think we need to do this together, but by all means, type this in or put it in on Winskip and or CyberDuck and take a look and see what happens. So this is that IMDb film example. I'm sorry, it does not work properly, but here's the deal. 4, 5, and 6, you know what that does. It declares a scalar, it prints a question, please enter a movie title, and then we chomp $film, which contains whatever our user entered. Godzilla or Them from the 1950s about giant radioactive mutant ants. What this used to do is go out to IMDb, grab the information about the movie, and bring it back in and display it in Perl. I suppose I could take over and fix it, but I really don't have time to do that for somebody else's Perl module. But the big deal here, and the reason it's in the if-else statements, is because you'll see that all of this stuff is in an if branch. So if we connect to the IMDb, we get all of that information out. Otherwise, our program puts out something didn't go right, and the IMDb connection error should give us a message about what the problem was. But again, I'm not going to do that today. I want to go on and talk about and, or, and not in a pretty solid way, actually. I hope I don't sound like a certain person in politics right now. So let's take a look at logical operators. Basically, logical operators mean this is what you can do in a condition to chain different expressions together. So if I wanted to find out if my user was male or female and over 65, or over 55 for that matter, I could do if sex equals male and age equals or greater than or equal. Let's use a greater than or equal to 55. You could probably run that program and find me, right? The not we saw in the last lecture, all that does is that flips the truth to false or the false to true. So it's pretty easy at a conceptual level, but let's go ahead and take a look at it code-wise. Again, we're stringing simple conditions together to basically say if all of these conditions are true or false, then we're going to tell you whether the output is true or false. Or we're going to run code rather based on whether the output is true or false. These are based on Boolean algebra, Boolean logic, true or false, right? On or off logic. And we can do any kind of conditions that we want inside the larger expression. We can do string comparisons and numeric comparisons together, and we can throw that not around if we need to for some not logic. And, or, and not. So 2 ampersands, the key above the 7 key on your keyboard is the logical and. 2 pipe characters, those are the straight line above the inner key, is a logical or, and of course the exclamation point is for logical not. I wish I'd stopped getting down that low. Anyway, here is an example of what we call a truth table. This is for the and. So in order for the and to be true in a greater expression, every part of its smaller expression has to be true. So if A and B are false, A and B are false. If A is false and B is true, A and B is still false. If A is true and B is false, again, it's still false. The only way an AND statement becomes true is if A is true and B is true, then the overall expression is true. So let's take a look at an example of that. Here we go. We're looking at, well, first of all, there's a problem with this program, and I would take points off of it if you did it. And it's easier for me to ask in a classroom and find out if somebody can see it, but online, we're not going to be able to do that very well. So I'll tell you that there's an error that exists. There's a line that should be in, about 3.5. And that 3.5 should tell the user what the program is, what it does, what it expects out of the user, and what it's going to return to the user for their time in, typing numbers into the screen. This is one of those cases where if it just said, enter your credit card number, would you do it? I certainly wouldn't. Even if it tells me what the credit card number is for, unless I know who I'm dealing with, I wouldn't do that either. So, user bin Perl, use modern Perl, all of that's the same as before. We can declare multiple variables in Perl by listing them in a comma delimited list inside of a set of parentheses. Okay, so we're declaring A, B, C, D, and E. These are really not good variables because they're single letters, and $A and $B are used elsewhere as part of the language. So I would rather see something like choice 1, choice 2, choice 3, choice 4, choice 5. Declare a variable that 100,000 lines of code later, you still know what choice 1 through 5 means. But you won't know, I guarantee you, what $X, $Y, $Z might be. So anyway, we're chomping and requesting that $A be filled with user input, $B, etc., etc. Line 6 is our if statement. It's actually an if else. So if $A is greater than 5, and $B is greater than 5, and C is greater than 5, and D is greater than 5, and E is greater than 5. All 5 of those are true in the sub-expressions. And you can put parentheses around these if you want to. Redundant parentheses don't do a damn thing. At least not when we're doing it like this. In mathematics, it changes a little bit, but for right now, all this does is say A greater than 5 is one simple expression. So if this is true, and this is true, and this is true, and this is true, and this is true, then they're all greater than 5. We go on with our lives happy, and our program terminates with a graceful exit. Otherwise, if even one of them is not true, we say they're not all greater than 5. I'm pretty sure that this one I do have, so let's check this out here. We're all the way up at the top, aren't we? Oh, come on. Well, let's figure out ASCII. Oh, that was the, okay. Well, I had the ASCIIs up there. Something 5. Ah, there we go, 5. So what's vim 5.pl? So I just have to remember what I'm doing here. And there we go. I've used my print statement to tell our user what the hell's going on. I'm not going to do this in the rest of them because it takes a lot of time to get them done. But this one kind of works for me right now. And I'm just going to take that space out. I think that space was a wasted space. And I also didn't change these from the Carnegie and Ritchie style. I left them, basically. After the first one, again, I like to have it in the GNU style. because then I can line up the curly braces just like I line up parentheses, or like you might line up parentheses in your math. So let's colon right and quit. Now let's Perl 5.pl. We're going to ask you to type 5 numbers, hitting the enter key at the end of each. If all are greater than 5, I'll let you know. So let's do 1, 5, 5, 5, 5. They're not all greater than 5. How about we try this again? 6, 7, 8, 9, 0, 5. They're not all greater than 5. That's because of the 0 in there. Let's try this again. 1, 2, 3, 4, 5. They're not all greater than 5. Let's do one more. Oh, it's not the 0. Duh. I forgot what we were checking for. We're checking to see if they're greater than 5. So 5, 6, 6, 6, 6. Why is the 5 throwing us up the error message? Let's go back and check the code. What do the comparisons say? A is greater than 5. What this last set of inputs was, with that 5 in the last one and the 0, 5 before, implied greater than or equal to 5. But they're not, so we have to have 6 or higher on everything. Let's go back and look at that then. Let's make a success here. There we go. So we're going to Perl this again. And 1, 2, 3, 4, 5. Now they're all greater than 5. So make sure that when you're setting up your inequalities that you have the right thing that you want. If you want 5 or greater, you should have greater than or equal to. If you want greater than 5, obviously it's greater than 5. So let's go back here and take a look at the next set. Whatever. So everything in the first half of the program is the same. But line 7 is different. So line 7, instead of saying $A greater than 5, instead we're saying if $A and $B and $C and $D and $E is greater than 5, then they're all greater than 5. Otherwise, they're not all greater than 5. Well, line 7, that sounds like something, I mean, we could figure it out, right? The implication there is if everything, all 5 of the variables is greater than 5, right? But let's see what happens. So this is going to be 5, 1, I think. All right. Well, my internet went out, and in order to do the Zoom thing, I have to have the internet present. So let's try this again. Off. Let's go ahead and restart my putty as well. So bear with me a minute, and then I'll share the screen for you, or with you rather. All right, so LS minus L. Good, I didn't even get it open. So I'm going to share my screen again and put my command bar down there. So because I hadn't gotten into this 51.pl, I don't have a swap file. If I had been in the middle of typing, I would have had a 51.swp. All that the swap file means is that Vim is trying to save your work because you just crashed, like I did. So what you need to do there is you can do ls space minus al, and that will show you a listing of all the system files that you have access to. And you can find .51.pl.swp or swq or something like that, and you can delete that, remove it. Otherwise, when you open the file a second time, it should give you the option to edit anyway or delete the swap file. Either one of those is fine if you have saved recently. If you haven't saved recently, you can always say recover, and that should give you a recovery copy of at least close to where you were working when the crash occurred. What we're looking at is we're looking at this particular slide, and this slide says, why will the statement below not work? And the line 7 is an if statement that says $A and $B and $C and $D and $E is greater than 5. Well, verbally, we know what that is, right? We know that what we've got is a mathematics equation where we want to check and see if all 5 of our variables are greater than 5. So let's vim 51.pl, and there you go. A, B, C, D, and E greater than 5. Okay. So let's Perl. I should have named the first one 5L. Oh well. Let's do that. Again, we don't have the sentence there, but let's just do all our 6s. Look at that. They're all greater than 5. It obviously works. If you only test one set of numbers, then you're right. It obviously works. Let's try this. 1, 2, 3, 4, and 6. Wait a minute. What's going on? Let's try one more time. 1, 2, 3, 4. So here's the deal. Fove 1. What we're actually testing is whether or not there is a value in $A. So if something's in $A, it's true. If something's in $B, it's true. $C, it's true. $D, it's true. And the only comparison we're actually making here is if $E is greater than 5. So let's do 2. So let's do 6 and 6 and 6 and 6 and 1. And that's a true statement. They're not all greater than 5, but the only thing that it checked was, is there something in the first 4 numbers, and then is the last number greater than 5? I want to do one more. So let's do 0 and 6 and 6 and 6 and 6. So the reason this failed is what? Because the first one has a 0 in it. And if you remember the early part of this lecture, you'll know that a 0 is false. So the other 4 were all true, but the first one was false. And with an AND statement, all of your conditions must be true. Let's do another one here. So instead of doing it that way then, Let's do a comma delimited list of numbers. So $A, comma, $B, comma, $C, comma, $D, comma, and $E is greater than 5. It works for, our print statement, right? We're just sending multiple arguments in. Well, let's see what happens. So let's Perl 52.pl. So what does that say? It says useless use of private variable in void context at line 16 for all 4 of them. 3, 3, 3, 3, and 3. The first 4 threes don't mean a darn thing. The only thing we're really checking on again in this, 1, 2, 3, 4, and 6, is that last variable. The only thing we're checking in those last two examples, were whether or not our $E's last input was greater than 5 or not. All right, let's come back here. This is an OR truth table. And ORs work a little bit differently. So if you're looking for every instructor over the age of 50, you could say, are they male or female? Doesn't matter. And then whether or not they're greater than 50 years old. So if in the first expression, they're neither male nor female, which happens, and they're 21, that would be false. They are not male or female and over the age of 50. But if either of the extra conditions or the other conditions, so if A is false and B is false, then the overall expression is false. If A is false and B is true, then we've got a true expression. Only one branch of an OR statement has to be true. If A is true and B is false, the combination is true. If both A and B are true, then obviously the combination is true. Wow. So let's see an example of this. So here what we've got is sort of a weird grade kind of in the class thing. It's not my grading scale, but what we've got is 2 variables, dollar semester average and dollar final exam. We ask our user to enter the semester average. We chomp it and put that in semester average. We ask our user to enter the final exam. We chomp it and put that in dollar final exam. And then line 8 through 10 says, if the semester average is over 90 or the final exam is greater than or equal to 5, say, congratulations, you get an A. Obviously, this is not my grade scale. But let's see, I think that's grades. So let's vim grades.pl. Nope. Usually I have a nice set of ORs here. And of course I don't. I tried to get everything prepped for today, but it doesn't work. So that's okay. We're going to come back up here. Whoops. We're going to go back down here for a minute. And let's vim or1.pl. Okay. I'll come over here and grab the code. Come on. back over into WinSkip. We're there, control. Oh, good, refresh. And we had OR1. And again, Control S saves it. You should have seen the disk drive or the floppy disk icon go from blue to nothing to grayed out. Well, let's double check here. There's our OR1. Again, we enter two variables and then we make a comparison using the OR statement. Remember that you can combine ORs as you need to make this all happen. So we're going to do Perl OR1.pl. My semester average sucked. I didn't turn any homework in. But I got a 99 on the exam. You get an A. Just the opposite. My buddy got all the homework done, but he bombed the test. He still gets an A. Student sitting over there in the corner by the window had a 99 on her homework or his homework and a 99 on the final exam or grade. Congratulations, you get an A. But Slacker Jones back there in the back row got a 12 on their semester average for their homework, got a 12 on the final exam, and they lose. They have to repeat the semester. So basically, anything except two fails in a single expression will make an OR statement true. So let's go back and look at this. This is our not truth table. And if you look, basically the only thing it does is it takes whatever the current expression is and flips it. So if A is false, not A becomes true. If A is true, not A becomes false. I really like the cartoon there. Penguins are black and white. Some old TV shows are black and white. Therefore, some penguins are old TV shows. My favorite one is we are taught to drive defensively, but coaches often tell their players that the best defense is a good offense. Therefore, we should all drive offensively. And that's a true statement. It's obviously true if you've been on the interstate about 5:30 in the afternoon. It sucks. So let's take a look at this. My dollar foo and dollar bar. Please don't use foo and bar. Basically, there's a military expression, F-U-B-A-R, which you can replace the F with any word you want, but I'll say is fouled up beyond all recognition. Programmers like to think that, at least in the early days, that it was cool to use words that had weird meanings. Hence foo-bar. Don't use foo and bar as, little wasted variables when you can't think of anything else. It's just, I just don't like it. And I would prefer that my students not do the same thing. Now, I do want to do, I was pretty sure I saw a not. There we go. So it's vim not.pl. So we've got dollar foo and dollar bar. We're chomping both of those as we input basically two words. If, I'm going to do the last one first. If foo does not equal bar, then we're going to say they're not equal. Up there, it says, in the middle parentheses, we do those first. Remember our order there. So foo equals bar. If that's true, that's good. So we've got not true. Not true is false. So if foo and bar are the same, that becomes true, but then we flip it to false, so we can say not equal. This first if statement is an example of what they call not logic. And for many beginning programmers, it is harder than hell to understand. You don't have to do it in most cases. There are some places where not logic is the best way to go, but not here, and really not for anything else that we're going to do in this class. So just keep it simple and use the regular dollar food is not equal dollar bar. All right, so let's see what that means. Let's run the code, in other words. So we're going to Perl not.pl, and let's just type in 1 and 2. They're not equal. Let's do this again. Let's do 1 and 1. Now, did you see me add an extra space after the 1? I haven't tried this in a while. Let's see what happens here. 1 space, and then 1 no space. So remember that what your user enters is important, because that literal space was part of making those 2 1s equal. When we put 1 literal space and hit the enter key, and then 1 hit the enter key, they were different. Pretty cool. So what else do we have here? Leap years. So a leap year is divisible by 4 and not divisible by 100, or it is divisible by 400. So we're going to use modulus arithmetic, remainder arithmetic, to determine if a year is divisible by 4, 100, or 400. So we need to find out whether our dollar year is mod 4 equals 0. Right? So 2,000 divided by 4 gives us 500. But it gives us no remainder. So that way it would not be, or it would be divisible by 4, pardon me. Dollar year mod 100 does not equal 0. So if it's the year 2020, we divide that by 100 and we get a leftover 20. So that would be true. Or a year mod 400 equals 0. In other words, it's divisible by 400. 2,000 would be divisible by 400, but 1,900 would not be. So let's join these up into an equation and see what happens, a program even. Now, I think I've got leap over here yet, but let's take a look and see. I do. So enter a year to test. Chomp dollar year and the diamond operator. So we're initializing and chomping year. Here's what we've got. So if dollar year, and we're using the numish operator that we just found out that Odin won't deal with. So let's get rid of that. Insert key would be nice. So instead of the numish operator, we're going to do the 2 equals because they're numbers. And at the same time, if year mod 100 doesn't equal 0, or notice we've got the and over here, right? Or dollar year mod 400 is 0. So 1600 was a leap year. I do have my insert key on. So let's try this. What we're doing is we're chaining together 3 expressions in a way that will give us the value of leap year or not leap year, based on the mathematics that we do here with the remainder division. So I'm going to quit. Enter a year to test. Let's try 2000. 2000 is a leap year. How about, this year? I was trying to send it a value and it's not accepting values. 2020. 2020 is a leap year because it matches all of the information that we fed it. So it is divisible by 4, but it's not divisible by 100, because we get a remainder out of 2020. Let's try one more. Let's try 1976. 76 was a leap year. It was also the year of America's bicentennial, but you probably are not old enough to even remember what that was all about. 200-year anniversary of the country. So here is our new order of precedence. Parentheses again first, increment or decrement second, exponentiation third. Our unary signs, positive, negative, or not. And then we get multiplicative. Then we get additive. Then we get our less than, greater than stuff. Then we check our equalities. And then we have ands and ors. Please notice that the and comes before the or. Again, it's left to right, like everything else we've talked about through the semester. But if you have an equation where you have a lot of expressions joined together, the ands will be done before the ors. If you don't, you'll get the wrong numbers out of it or the wrong condition out of it. And I'll put a couple of examples of this and their solutions out on Canvas. So I'm going to stop the share right now, and I'm going to stop the recording as well. And I'm going to pick up another pair right now. So we will have this posted along with the next lecture posted this afternoon. Have a good evening or good afternoon. There I am. And we'll talk to you guys later.